Okay, guys, we're going to look at some quadratic word problems, and we're really going to look at three types here. The first type is really a straightforward, just take what the math means in the equation. So it says the sum, so that means we're adding. Okay, we're going to add a number. I don't know what that number is. Let's say we call it x, and its square, which means I'm going to take this x and I'm going to square it. And it says that is in math means equals, and it says it is, in this case, 56. So there's my equation. X, the number, plus sum, the square of that number, its square, is equals 56. So I'm going to solve this, and it's a quadratic. It's got a squared term and a linear term, so I'm going to have to solve this by factoring. So I'm going to get it set equal to 0 first. And while I'm doing this, guys, I'm going to go ahead and kind of put this in a different order. I'm going to put the squared first, then the x, then the minus 56 equals 0. And then I'm going to factor like we've done the last few days. Okay, x and x. Two things multiplied to be negative 56 had to be 1. I think that's a positive 8. And then negative 7. Then I'm going to take both of these and set them equal to 0. And solve. So I get x equals negative 8. Or x equals 7. And that would be your solution. You have two solutions here. You could either have 8 or negative 8 and 7. If I take negative 8 and add it to its square, negative 8 squared, that'd be 64. Negative 8 plus 64, is that 56? I think so. And then 7 and its square, which would be 7 squared, 49, is 7 plus 49. 56? Yeah, I think so. So I think that works for both of those. So negative 8 and 7 would be your solution here. Okay, the next one we're going to do is a consecutive integer problem. So in this case, we have the two consecutive even integers. Well, if it's even integers, the first one would be x. The second one would be x plus 2. The evens skip every 2. If we just had regular integers, it'd be x and x plus 1. If we had odd integers, x and x plus 2 would be the same thing. So in this case, it says their product. Product means multiply. So I'm going to take x. I'm going to multiply it times x plus 2. That says that product is 168. So once again, you say, oh, well, what can I do here? Well, we're going to have to go ahead and do distributive property here. So it's x squared plus 2x equals 168. And then we got to get it set equal to 0. So x squared plus 2x minus 168 equals 0. Let's factor that non-zero side here. It's going to be a little bit harder here. X and x. I definitely know one of them is going to be a positive, one of them is going to be a negative here. So what two things multiply to be 168, but they're different? When I add those two together, that's 2. Well, let me see here. I definitely know it's not 2 times 84. I think 4 goes into that, but 4 would go into that 42. So I definitely know it's not that. I think I'm going to do 14 times 12. No, I'm going to tell you, I just kind of take a calculator and said, boy, I think maybe 12 goes into that. Since 2 did, since 4 did, just maybe a possibility, and it does go in there, 14 times 12, and that is negative 168, and it is positive 2. And guys, you're just going to have to experiment. I don't think you have quite as big a numbers here, but I mean, you could. So you're just going to have to keep going until you find one that work here. So it's x plus 14 equals 0, or x minus 12 equals 0. So we're going to subtract 14 here. So we get x equals negative 14. And then for this one, we get x equals 12. Now, normally you'd say, oh, I'm done like I was in the last one, but really you're not. Because what I want to know is I want to find both numbers. Have I found both numbers? Does 14 times 12 equal 168, negative 12? Negative 14 times 12 equal negative 68? No. So what I have to do is I've got to take this negative 14. Okay, I got to take this negative 14. I got to plug it in here. So my first term would be negative 14. And my second one would be negative 14 plus 2, which would be negative 12. So one of the combinations that work is negative 14 and negative 12. When I multiply those, I get a positive 168, and those are consecutive even integers. And then for the second one, guys, I'm going to have to take this 12, and I'm going to have to plug it in here. So the first one will be 12. The second one will be 12 plus 2, which is 14. So the OR here would be 12 and 14. So truthfully, you kind of get 4 numbers here. You're going to get a 2 with the negatives, and you're going to get 2 numbers with the positive. Either one of those are consecutive even integers whose product is 168, positive 168. So maybe just a little bit more to do here after you find your 2 numbers. You got to go back, plug them in, and find both sets of solutions here. So when it says find both numbers, there really ought to be 2 sets of solutions here for this consecutive integer problem. Okay, let's look at the last one, which is it's kind of a geometry problem here. I've got a rectangle here. Okay, and it says the perimeter of this rectangle is 28. So I know the perimeter of this rectangle is 28. And then it says its area is 45. What are the dimensions? Well, that's interesting. Well, I'm going to tell you, what we have to do here is a little bit of going back to solving the system, because perimeter is 2L plus 2W, and I know that equals 28. And area is length times width for a rectangle. So now what I have are 2 equations and 2 variables. And I'm going to tell you, you probably don't want to graph those. You probably definitely cannot do elimination. What you're going to have to do is substitution here. So you're going to take the area one, and you're going to solve it for one of these variables. It doesn't matter which. I'm going to go ahead and solve it for L. So I get L equals 45 over W. So in the other equation, instead of L, I'm going to substitute in that 45 over W. And I will tell you, all of these, you can do the same exact way here, guys. And then I'm going to go ahead and multiply this by 2, so that's really 90 over W plus 2W equal 28. I know you're probably saying, what in the world do I do here? Well, we're going to go ahead and let's get rid of this fraction, guys. We don't like fractions. I don't like them a whole lot more than you do. So let's multiply everything by W, which is that denominator. So the w's cancel out here. You're left with 90. This is 2w squared. Okay, and this is 28w when you multiply everything by w to get rid of that fraction. Now, I've got an equation that looks like something I've done before. So I'm going to get this set equal to 0. Once again, my largest degree is positive, so I'm going to move this one over, get it set equal to 0. I'm going to rearrange the order here so it's easier for us to factor. And then I see a common factor of 2 here, so I'm going to factor that out. And then I'm going to go ahead and do my factoring here. So I get W and W, two things that multiply to be 45, add to be negative 14. I think that's negative 9 and negative 5. So W minus 9 equals 0. Once again, this 2 you can ignore. It can't be 0. W minus 5 equals 0. So I'm going to add 9, add 9. So I get W equals 9, add 5, add 5. I get W equals 5. And you say, Mr. Firstmuller, how can the width be two different numbers? And the answer is, it can't be. It's one of these two. In fact, these two numbers are actually your two dimensions. Now, the width we usually use is smaller, so we'll do the width is 5. And the length is 9. Okay, so a little shortcut. You don't really have to go back in and plug it back in and find the other. When you do this, the two numbers you're going to come up with are your two dimensions. And we usually do the width is smaller than the length. So we'll do the width as the smaller one, the length is the bigger one. I don't know if they gave me units here. They didn't give me any units here, so we're not going to worry about it. So the width is 5 and the length is 9. Okay, guys, really this one's definitely, of all of them, going to be your most difficult one here. So your homework for tonight, guys, on page 199, 200. We should be great at solving by factoring by now here. You're going to do 1 through 6. Okay, and there's just problems 1 through 6. And that's it.